we define a vector as an object with a length and a direction. However, there is one important thing. The vectors are having direction. The zero vector, the unit vector having zero length with no length. The zero vector is not pointing in any particular direction. You can see that it has an undefined direction. Zero vector is vector which has zero magnitude and arbitrary direction. If you multiply it with any vector with 0, its result cannot be taken as 0. It should be written as a 0 vector. 0 is a real number and 0 vector has magnitude 0 as well as direction. 0 vector refers to the additivity identity element in any vector space, and you can also see that the position vector of origin of the coordinate axis is a 0 vector. The displacement of stationary particle from time to time, it is a 0 vector. The displacement of ball throw and receive back of the thrower is a 0 vector. The velocity of vector stationary body is a 0 vector, and also that the acceleration of the vector of body in uniform motion is a 0 vector. For an example, if you walk down the street following the south direction for 1 kilometer and again come back to your initial place, or the point following the north direction for the same distance, you can also see that north and south are just opposite direction, and in this case you have walked for 1 kilometer, which implies that the magnitude of distance covered is 2 kilometer actually, but according to the algebra of vector, you are the same position from where you have started, or we can say that the final position and initial position are same. So that you can also see that here displacement get nullified, but you are still facing the northern direction. This is where the significance of null vector or 0 vector lies. Even the magnitude of vector is 0, we can still get the direction in it. The properties of 0 vector. If we add 0 vector to any other non-zero vector, the result will again be that non-zero vector. Second, you can also see that if we subtract 0 vector to any other non-zero vector, the result will be that the non-zero vector. Third, if you multiply 0 vector to any other non-zero vector, you can also see that here the resultant will be a 0 vector instead of a non-zero vector. Fourth one, when a 0 vector is multiplied by a non-zero scalar, its result will be a 0 vector.